Okay, hello viewers, and welcome to a live solve, a pencilless live solve of the 2020 AMC 8. So I have not seen these questions before, and I will not use a pencil. You just have to keep my word for it. Um, but let's get started. Before we start, just a note, live solving AMC 8 questions is nothing impressive. I mean, these are questions for 8th graders, of course. But I mean, this could be a precursor to live solving AMC 10. So I was just thinking, why not? I haven't seen this set of questions anyways, so let's go for it. Okay, problem 1. Lucas making lemonade to sell at a school fundraiser. His recipe requires 4 times as much water as sugar and twice as much sugar as lemon. So that's 8 times as many water as lemon, I assume. He uses 3 cups of lemon juice. How many cups of water? Well, okay, we just did the answer, right? If he uses 3 cups of lemon juice, twice as much sugar as lemon, so he has 6 cups of sugar. And then 4 times as much water as sugar. So he needs 6 times, whatchamacallit, 4? So he'll need 24 cups of water. So that would be E. Okay, problem 2. 4 friends do yard work for their neighbors, earning a bunch of money. They decide to split their earnings among themselves. How much in total will the friend who earned $40 give to the others? Okay, well, I guess he's getting scammed. But so the sum of all these costs, well, is just 100. So we divide by 4, that'll be 25. So he'll be paying $15. So it would be C, $15. Okay, let's move on. Problem 3. Carrie has a rectangular garden that measures 6 feet by 8 feet. That's 48 feet by total. She plants an entire garden with strawberry plants. She's able to plant 4 strawberry plants per square foot and harvest an average of 10 strawberries per plant. Excuse me. Okay, sure. So she has 48 square feet of planting room. And then you get 4 strawberry plants per square foot. So we multiply by 4 and then multiply by 10. So what's 48 times 4? Well, we multiply by 2, we get 96. Then we multiply by 2 again, we get 192. Then we multiply by 10. So it should be D, 1920. Problem 4, through hexagons increasing size, dot pattern. One more bit of dots. How many dots are in the next hexagon? Well, we can just, well, crap, we can't count. But you know what? Because we're pencilless, we can notice patterns. Each band is 6n except for the center band, which only has 1. So the next band has 3 times 6, which is 18. So 18 plus how many dots are in the current one was our answer. I can't really bother to add the current one. So it's just 1 plus 2 times plus 3. So this is just 37. So it's probably just B. And the way is, I know it's pencilless, but I'll just move my cursor to show you guys. So if you count from each corner and go right, this is 2, this is 2, this is 2, this is 2, 2, 2. So this is 2 times 6, 1 for each corner. Here it's 1 for each corner, that's 6 times 1. In the center, it's weird because it's not 0, it's 1. So if we add the next band, it's 3 times 6 plus 2 times 6 plus 1 times 6 plus 1. That's 1 plus 2 times 1 plus 2 plus 3 times 6 plus 1. That's 6 times 6 plus 1, which is 37, which is B. Okay, pick problem 4. 3/4 of the pitcher filled with, let me just make sure I read that right. Yeah. 3/4 of the pitcher filled with pineapple juice. The pitcher is emptied, pouring an equal amount of juice into each of 5 cups. What percent of total capacity of the pitcher did each cup receive? 3/4 is 75%. If we pour 75% into 5 cups, it's 75 divided by 5 is 15%. So the answer is C. Problem 6. Aaron, Darren, Karen, what? Wow, rhyming names. Aaron, Darren, Karen, Marin, and Sharon rode on a small train. That's 5 cars that seat 1 person each. Aaron sat in the last car. Aaron sat behind Sharon. Darren sat in one of the cars in front of Aaron. At least 1 person sat between Karen and Darren. Interesting. So, I mean, we can just guess, it's probably Karen, Sharon, Aaron, Karen, Sharon, Aaron, Darren, and Marin. Does that work? Sorry, Karen, Darren, Sharon, Aaron, and Marin. Karen? No, 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 no. Okay, sorry. Sharon? Okay, there's a person between Karen and Darren. So it's probably Karen, Sharon, Aaron, Darren? No. Aaron sits behind Sharon. Oh, no, no, no. It's Karen. What? There's 1 person between Karen and Darren. Darren is son of Aaron, and Aaron sat directly behind Sharon. How does this make any sense? No, wait, okay, sorry. So Karen has to sit in the back. So okay, in that case, it has to be Darren, Sharon, Aaron, Karen, and Marin. Darren, Sharon, Karen, Aaron, and Marin. So let's check that. Darren. So Marin is in the last card, that's right. Darren, Karen, Sharon, Aaron, and Marin. So Aaron is behind Sharon. Darren, Karen, Sharon, Aaron, Marin. Derek is in front of Aaron, that's correct. Darren, Karen, Sharon, Aaron, and Marin. At least one person between Karen and Darren, that's correct. Darren, Sharon, Karen, Aaron, and Marin. Okay, then we're just done. So Darren, Sharon, Karen, Aaron, and Marin. No. Oh my goodness. Wait. Darren, Sharon, Aaron, Karen, Marin. Darren, Sharon, Aaron, Karen, Marin. Darren, Sharon, Aaron. Okay, so the middle card is Aaron. Okay, then it's A. A for Aaron. Problem 7. How many integers between blah 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 have 46 changes remaining? Okay, cool. So obviously the first digit is 2. That's just like simple. The next one has 15, like increasing. Well, okay. So the key to the question I think is it doesn't really matter if it's like 2000 or 2020 because like all the other digits are greater than 2 anyways, right? So I think it's pretty clear. Really, we just want 3 increasing numbers. Uh, where well we can't have 4 obviously because the other two have to be greater than 0. So we just have the first number has to be 3. That's pretty clear because it can't be 2. It's not increasing. It can be 4 because then the other ones are greater than 2,400. That's be 2 and then 3. And then the last two are just any two numbers that are increasing um, that are like anything. So it's like you can have 0 and then the other one. The 10th digit can be 0 and the other one can be 1 to 9. And then the 10th digit can be 1, the other can be like 2 to 9. So in general, it's like 9 plus 8 plus 7, etc., down to 1. So that's just a sum 45. So the answer should be 45. No, because 3 is in the hundreds. I mean, yeah, 3 is in the hundreds place. So the next one has to be 4. So it has to be 4, and then 5, 6, 7, 8, 9. That's 5 numbers. So 5 plus 4 plus 3 plus 2 plus 1. That's 15. So the answer is C, 15. Okay, coolio. Problem 8. Ricardo has 20 coins, some are winner pennies, and the rest are winner nickel. He has at least 1 penny and at least 1 nickel. What is the difference between greatest possible and least possible amount of money? Okay, well, that's pretty simple. If I'm greedy, I just ask for 1 penny and the rest of all my things are nickels. If I'm like, I don't know, weird, I have 2019 pennies and 1 nickel. The difference is just going to be, uh, well, it's 1 times 1 plus 2019 times 5 minus 2019 times 1 plus 1 times 5. That's just going to be 2018 times 4, I believe. Is that correct? Yeah, 2018 times 4. What is 2018 times 4? That's just 8,000 plus 18 times 4, which is 36, times 2, which is 72. So 8,072. That should be C. Okay. And in cents, so we're correct. Akash's birthday cake is kind of formed 4 by 4 by 4 inch cube. The cake has icing on top and the fourth side faces no icing in the bottom. Suppose it can 64 smaller cubes, each measuring, etc. Okay, hold on. Icing on the top and 4 side faces. Okay, no bottom, no bottom. How many small pieces will have icing on exactly 2 sides? Well, okay. So obviously it's not going to be any of the. Oh, it could be. It could be some of the cubes in the bottom. It's not in the middle of the bottom, obviously, because this is just a 0. So it could be this edge here, this edge here, this edge here. That's total of 12 because there's 4 edges. And then these center things are pretty useless because they only have 1. Then we just look at the top face. This one has 3, impossible. This one has 3. These middle ones only have 1. It has to be these two on the side, exactly 2 sides. So it'll be 2 times 4, 8 plus 2 times 4. I mean 3 times 4, which is 12. That should be 20. D. It'll be 1, 2, 3, 1, 2, and then you just rotate that 4 times. Those will be all your cubes, I believe. Yeah. Okay. So the answer is D here. 20. Zara has a collection of 4 marbles, Aggie, B, S, T. She wants to display them on a row and shelf, but does not want to put Steely and Tiger next to each other. Why not? Come on. Come on, Zara. Okay, anyways. This is obviously, we just want to eliminate the cases where Steely and Tiger sit next to each other. Well, how many ways can we arrange them? Well, there's 24 because it's 4 factorial. How many ways to put Steely and Tiger next to each other? Well, if we make Steely and Tiger one compound marble, call it the steel tiger. Then we have Aggie, the steel tiger, and Bumblebee. There's 6 ways to rearrange this, but Steely and Tiger can swap orders. So it's actually 6 times 2, which is 12. Now 24 minus those 12 bad cases gives 12 as her answer. So there's 12 ways she can do this. So she does not want to put Steely and Tiger next to each other. Let me just check over. That's like 2 times 6, 12, 24 minus 12. It should be 12. Yeah. So it's probably C. After school, Maya and Naomi headed to the beach, 6 miles away. Naomi is a freaking speedster. 6 miles away, Maya decided to bike where Naomi took a bus. Yeah, okay, that makes sense. Maya, dang. Okay, the graph shows the journeys in time distance traveled, a space-time graph or something. What's the difference in miles per hour between Naomi's and Maya's average speeds? That isn't too hard. So Naomi drove 6 miles in 10 minutes. Miles per hour. So that means she could drive 36 miles, which is multiplied by 6 in 60 minutes. So she's 36 miles per hour. Maya drove 6 in 30 minutes. That means if we gave her twice the time again, she would drive 12 miles. So Naomi can do 36 miles per hour. Maya can only do 12 miles per hour. So the difference is 24 miles per hour. I assume, right? Yeah, it should be E. Okay, problem 12. Positive integer n in factorial notation, n factorial represents the product of the integers from n to 1. For example, what value of n satisfies the following equation? Okay, well, this looks like a pain, but it's probably not too hard because n is only strictly increasing. Okay, I'm doing a proof for some reason. I'm not taking the use memo or anything. So this is just like do whatever. Okay, 120 times 9 factorial equals 12 times n. That's just 10 times 9 factorial, so n is just 10. And the reason for that is 5 factorial, don't compute 9 factorial. That's just a pain and it's going to waste a bunch of time. I'm just going to explain like 5 factorial is 120. So if we divide 12 on both sides, it becomes 10 times 9 factorial equals n factorial. 10 times 9 factorial is just 10 times 9 times 8 times 7 times, etc., which is just 10 factorial. So n factorial equals 10 factorial, so n equals 10. Okay, the answer is A. Problem 13, Jamal has a drawer, 6 green socks, 18 purple socks, 12 orange socks. Adding more purple socks, now there's 60%, it's randomly purple. How many purple socks did Jamal add? Okay, that isn't too hard. So there's total 36 socks and 18 purple socks, right? So 18 plus, let's say he added X purple socks, and 18 plus X over 36 plus X is equal to 60%. So that's 3/5. 18 plus X times 5, that is an interesting, that's 90 plus 5X equals, 90 plus 5X equals 108 plus 3X. So 2x equals 18, so it should be 9. Let's just check that over. So if he adds 9 purple socks, then there's a total of 45 socks total. And he has 27 purple socks, so 27 over 45. That's 3 over 5, 60%. So Jamal added 9 purple socks. So there's B. Okay, problem 24. There are 20 cities in the county of Newton. Interesting. Was Newton a count? I don't know. Okay, 20 cities. Oh my goodness, that bar chart looks horrible. Okay, the populations are shown in the bar chart below. Average population in all cities is indicated by a horizontal dash line. Really? That's kind of hard to believe. I'm not gonna lie. Okay, maybe it isn't too hard to believe because these two bars are really short. These two bars kind of fill it out, and this kind of might fill this gap over here. Okay, I can believe that. Horizontal dash line. Which of the following is close to total population? Oh my goodness. Okay, but that is too hard. What is this number here? This number in the middle is like, why is this so annoying? Okay, these are 4 dashed lines. So each of those dashed lines should be about 250 people. So if we go 250 up and then we go half of 250, which is 125, we should have about 4,375 people on average. So what's 4,375 times 20? Well, that's kind of a pain, isn't it? Yeah, that's kind of a pain. That's a real pain. Okay, whatever. So be it. So 4,000 times 20 is 80,000. 375 times 20 is 750 times 10, which is 7,500. 7,500 plus 87500. Huh? Okay, well, I guess it just because I guess that's weird question. It should have been more accurate, but it's like, yeah, C, 85000. Seems about right. You know, I'm just gonna check. That divided by 20 is like about like 4,200. Does that seem about right? You know, it's not right, but you know, like the question probably isn't too accurate either. So you know what? Whatever, right? I mean, like this next answer choice definitely isn't it, right? If we divide by 20, that's about 4,700, which is way above half of this. No, wait, I am actually okay. Saved by the check. See, this is why you need to read the scale. This is 2,000. So each of these little gaps is actually 500. So this should actually be about 4,750, which is 4,750 times 20. That should be 80,000 plus 750 times 20 should be 1,500. Should be 1,500. There should be about, yeah, D. This is D. Okay. Somehow I was saved by the question being too accurate. See, you can never um, take not sillying for granted. They're always going to be there. The answer is D, 95,000. Okay. 15% of x equals 20% of y, what percentage of x is y? Okay, well, that's a pain. What if x equals, I don't know. Let's make this simple. 20% of y is 1/5 of y, right? So if x is 100, then 15% of x is 15. So that's 1/5 of y, so y is 75. What percentage of 100 is 75? Is 75%, so just C. Okay, not too hard. Yep, not too hard. What percentage of 100 is 75? 75 is 75% of 100. Okay, yeah. Just make sure it makes sense. C. Prompt 16, each of them is a different digit from 1 to 6. Okay, sure. What? Wait, why? That's okay, that's kind of weird. It's like, what is this? Different digit from 1 to 6. Each of the 5 lines shown passes through some of these points. Let me just count 1, 2, 3, 4, 5. Okay. The digits along each line are added to produce 5 sums, one for each line. Total of 5 sums is 47. What is the digit representative may be? This is kind of a pain. Okay, A is added twice, F is added twice, E is added twice, D is added twice, C is added twice, B is added thrice. So the total of the 5 sums is 47. So the sum of A to F is 21. So everything is counted twice, so it's 42, except B is counted thrice, so there's one extra count. So that means that one extra B is why this is 47 instead of 42. That means B has to equal 5 and we're done. So B equals 5. The others are probably just whatever. Like they could be any numbers, so it's a bad idea to try to guess this question. Yep. Okay. But I think if you just guess the question, you can probably get it right too. Okay, anyways. Just make sure 42, 7, 5. Okay, yeah, cool. This is E. Problem 17, how many factors does 2020 have more than 3 factors, etc.? Okay, well, this is kind of a pain, right? More than 3 factors, what does that even mean? Well, okay, I guess we can just get rid of the ones with exactly 3, 2, or 1 factor. So 1 factor is obviously just 1. 2 factors is obviously just the primes. How many prime factors are there? 2020 is like, I don't know. It's been so long since I've factored this. Like 4 times 505. It'd be 2 squared times 5 times 101. So there should be 3 distinct prime factors. Um, so now we have 4 bad numbers. And now which ones have exactly 3 factors? Well, 3 is odd, which means it have to be a perfect square. And in particular, it has to be a prime to the perfect square. So there's only one, right? 4, because 4 times 5 times 101. So 4 should be the only bad one there. So in total, there should be 5 bad ones. So if we subtract 5 from the total number of factors of 2020, we should be done. 2020 has 3 times 2 times 2 equals 12 factors, minus 5 should be 7, so the answer should be B. I believe. It's got to be B, right? If it's not B, it's got to be B. Yeah, it's probably B. Okay. B. Come on. B, is it B? 12 minus 5 is 7. Okay, it's got to be B. Let's say the answer is just B, 7. But problem 18, rectangle ABCD is inscribed in that looks like a square, buddy. That looks like a square. Like you can't convince me otherwise. Um, rectangle ABCD is kind of okay. Whatever. GA equals 16. FD. What is this spirit condition? Equals 9. What is the area of ABCD? Okay, that shouldn't be too hard. What is the radius? The radius is from center to here is 8, and then we go another 9, that should be 17. So the radius is 17, and so this length is 17, this length is 8, so this length is 15 by Pythagorean theorem. So, okay, well, if a rectangle has sides 16 and 15, I really can't tell the difference. It's probably just a square, right? So this is some kind of troll question. It better not have 16 squared on here. Oh, it does have 16 squared on here. See, this is why AMC questions are always evil. Like, dude, that's clearly a square. But anyways, okay. BA is equal to 15 because Pythagorean theorem. 17, 8, 15 is a well-known triple. So what is the area? This is 15 times 18. I'm sorry, 15 times 16 is 8 times 30, which is 240. So that's our answer. Yep, this is kind of a troll answer. Answer is A. Problem 19, number is called Flippy if its digits alternate between two distinct digits. Flippy, not Flippy. Huh, okay. How many 5-digit Flippy numbers are divisible by 15? Okay, so I assume 5-digit Flippy numbers means like A, B, A, B, A. So first of all, it's divisible by 15. The last number has to be 5 or 0. It's obviously not 0 because then the first digit is 0, which is not a 5-digit number. So the last number has to be 5. So it has to be 5A, 5A, 5. Now, it also has to be divisible by 3. 5 is already satisfied. We just need divisibility by 3. So 5 plus, we just need some of the digits to be a multiple 3. 5 plus 5 5 is already a multiple 3. We just need A to be multiple 3. And it's just 5, 3, 5, 3, 5, 5, 6, 5, 6, 5, and 5, 9, 5, 9, 5. And that's all. So it's probably A. Is that right? It's gotta be right. No, it's not right. I am actually questionable. So it can also be 5, 0, 5, 0, 5 because 0 is also multiple 3. So 0, 3, 6, 9. I'll bet some people got that wrong because of that like little issue there. So then I guess it's just 5. So it's just answers B, 4. Yeah, probably just B. Okay, prompt 20. Scientists walking through a forest record as integers. The height of 5 trees standing in a row. She observes that each tree was either twice as tall, half as tall as the one to their right. Unfortunately, one of the was lost. Oh, well, that's unfortunate. That is also relatable. Oh my goodness, this scientist is, dang, he's got a hard life. Observe that each tree is either twice as tall or half as tall to the one to its right. So it's just multiplied by 2 divided by 2. Okay, sure. Unfortunately, some of our data was lost when rain fell on a notebook. Notes are shown below. Based on our observations, scientists were able to reconstruct the lost data. Was the average height of the tree in meters? Well, that's kind of a pain, right? Well, obviously tree 1 is 22 because you can't divide by 2. They're integers. Tree 3 is obviously 22 as well. Now the real question is tree 4 and tree 5. But the key here is that the average height is 0.2. So if we take that times 5, then the number has to be 1 mod 5, right? Tree 1 plus tree 2 plus tree 3 gives the number 0 mod 5. So now we just look at the other possibilities. Tree 4 is 44, tree 2 is 22 is possible. Tree 4 is 11, tree 2 is 22 is not possible. Tree 4 is 44 and tree 5 is 88. What about that? That's also not possible. So it has to be 44, 22. That's not too hard. So our trees are 22, 11, 22, 44, 22. That should be 11 times 1 plus 2 plus 2 plus 2 plus 4. That's like 5 plus 6. That's 11 times 11, which is 121 divided by 5. That's like 24.2. Yeah, sounds about right. 24.2. Okay, then the answer is just B. Let me just check this over. 22, 11, 22, 44, 22. That's got to be right, right? 6 plus 5, 11 times 11, 121. 121 divided by 5. Yeah, it's got to be right. Okay, answer is B. Average height of the tree in meters shall be B. Let me just check these are in meters. Yep. Okay. Problem 21, game board 64 squares alternate in color between black and white. Figure shows square P in the bottom row and square Q in the top row. One displays a P step moving the marker into one of the joining what square? How many 7-step paths are there from P to Q? Oh no, this is such a pain. Dang it. This is why this is hard. Or at least non-trivial. Okay. It's time to think. This is not gonna be easy. Because normally this is such a pain. Or is it really such a pain? I can do something clever here. So I guess I'll help you guys visualize this. I can't use a pencil, but I'll use my cursor to show you guys what I'm talking about. So this is a path from P to Q, but if we extend the checkerboard out here to include 3 more squares, then this becomes a rectangle, which is counted by the Pascal numbers, the number of paths. But it's not a rectangle because those squares don't exist. They're just a figment of our imagination. But we can get around that by looking at how many paths pass through these squares and subtracting that out from the Pascal number to get the answer. So we can just basically counting which paths don't work. So which paths don't work? Those are easy to count. So we have 1. Let's look at the ones that pass through this one first. So we have 1, we have 2, we have 3, and we have 4. That's pretty simple. Those are all the paths that pass through this missing square here. Well, what about if it doesn't pass through this square? Then it also doesn't pass through this square. It has to pass through this square. So there's only one path. This, this, this. So how many paths total are bad? 1, 2, 3, 4, 5. So we just need to subtract out 5 paths and then we're done. So it shouldn't be too hard to do, right? Yo, we actually, okay, sorry. I actually just got bamboozled. So this is sure one path. Um, this is another path. Oh, those four were correct. But I still got bamboozled. Why? Because I thought the only path to get to here is this one. But is that actually true? No, that is not actually true. Because actually in the beginning we can go right and then go here. Or we can go up to here and then go here. So actually I got bamboozled 3 times. There's one bad path, two bad paths, and three bad paths. The triple bamboozle. What can I say? It's hard, man. So 3 plus 5, I mean, sorry, 3 plus 4 is the total number of trickery wrong paths there are. So let's see, 3 plus 4, that's got to be 7, right? If the 3 plus 4 is not 7, I would be confused. Okay, 3 plus 4 is 7. So how many total paths are there from P to Q? So now this is the less hard part because now this is Pascal's triangle simply. This here is one choose one, two choose two, 3 choose 2, 4 choose 3, 5 choose 3, 6 choose 4, 7 choose 4. 7 choose 4 minus 5 should be our answer. What is 7 choose 4? That should be 7 choose 3, which is 5, 6. There should be 35 minus the 7 bad paths. It should be A, if I am correct. It should be A because there was 35 paths total from P to Q. That's just 7 choose 3, the Pascal number. But 7 of those are bad. And precisely which 7? Well, it's pretty simple. It's this bad path, 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 and that's all. So 35 minus 7 is 28. I'm sure some people made the bamboozle decision to forget these two, and that's why B exists. This is a very evil question. I'm not going to lie. I'll bet you some people even answered E because they didn't notice that you can't go through squares that don't exist. At least that's what I think. Okay, anyways, I think the answer is A. Let's move on. Oh my goodness, what is this? Is this some kind of Collat's conjecture? Is this like an AMC question now? Having middle schoolers prove the Collat's conjecture in their free time? When a positive integer n is sent to a machine, etc. Okay, seems like a pain. For example, 7, 22, and then 11, 34, 17, 30, 52, 26. Okay, well, that's kind of annoying. Same step process applied to a different starting value of n, the final output is 1. What is some such, oh no, this is going to be such a pain. Okay, it's applied 6 times to n. Come on. Are you kidding me? Okay, this is such a pain. Okay, this might be the hardest one so far. It's not going to be easy for sure. At least this one has to be 2 because, yeah. Or is it? Okay, positive integer n. Okay, yeah, this one has to be 2. This one has to be 4. Now, this is where things start getting annoying. Because this one can be 1 or it can be 8. You know what? Let's get the simple things out of the way first. So if this one is 1, then this is 2, this is 4 again, and it has to be 1 or 8. So then we just need to add 9. Okay, now it's time to remember. Don't forget to add 9. Okay, don't forget to add 9. Okay, perfect. So 1, 2, 4, 1, 2, 4, 8. 8 cannot be 3n plus 1. That's pretty clear. So the next one has to be 16. 16 can be 3n plus 1. Now this is where we have another pain. This can be, it can fork into 5 or 32. Let's do 32 because it seems simpler. If it's 32, there's no 3n plus 1 that gives 32, so n has to be 64. Let's add 64 to 9, and that gives us 73. Okay, 73, 73, 73, keep that in mind. 73, we'll add that on later. And now we look at what happens when this is equal to 5. 3 times 5 plus 1 equals 16. So what gives 5? Well, obviously 3 times n plus 1 can't be 5. So n has to be 10. So we just need to add 10 to 73 and get E, 83. Now, let me just make sure I didn't overlap. Our possible answers are 1, 8, 10, 64. 1, 8, 10, 64. Do those add to 83? 1, 8, 10, 19 plus 64. Yeah, 83. So I think the answer is just E. Okay, problem 23, 5 different awards. Wait, am I trolling? 1, 4, 2, 1, 4, 2, 1. Okay, it's got to be right. Okay, problem 23, 5 different awards given to 3 students. Each student receives at least 1 award. How many different ways can the awards be distributed? Well, that's not too hard, is it? 5 different awards given to 3 students. Each student receives at least 1 award. Okay, maybe it's not so simple. Let's see what's happening here. Let's say, okay, each student has to be unique, right? Because people are unique, of course. Um, in that case, I guess we just need to take the total number of cases and subtract away the cases where a student receives no award. That's seems like kind of annoying. You know, so be it. Let's do it. So let's say student A receives no award, then student B and C have to split the remaining awards. Okay, how many are there? That's just 2 to the 5th, which is 32, I believe. Is that true? It's got to be true, right? Yeah, it's got to be true. Okay, so 32, and then we can do pi here. We're just doing some double counting elimination. So how many ways are there for 2 students to both receive no awards? Well, the third student just receives all the awards. So there's just 1. Okay, so the answer should be 32 plus 32 plus 32 minus 1 minus 1 minus 1. Is that possible? It's got to be possible. It is, right? 32? Okay. That's 96 minus 3, which is 93. So 93 bad ways, 5 different awards, that should be 3 to the 5th. 3 to the 5th is 243 minus 93. That should be 150. So it should be B. It's gotta be B, right? It's gotta be B, right? Question mark? Big question mark? It's gotta be B. Two hundred fifty, 243 minus 93. 240 minus 90, 150. Okay, I am a believer, and I believe that it's B, so it's gotta be B. Yep. Problem 24, large scale region, pale with n squared grade square tiles, measuring s inches on its side. Oh no, this is such a pain. Come on. Are you kidding me? Large scale region paved with n squared gray square tiles, each measuring s inches on its side. Uh, a border d inches wide surrounds each tile. Huh? I guess that's just this border, right? Okay. Um, shows the case for n equals 3. The 576 gray tiles cover 60% of the area. What's the ratio d over s? Are you kidding me? Why do I need to calculate the ratio d over s for you? Come on. Are you kidding me? Come on. Okay, whatever. You know what? I'm going to use the power of reverse engineering because I don't want to do the algebra. I'm going to look at these solutions and then I'm going to stare carefully at them. I notice this one's a perfect square and this one's a perfect square and this one's a perfect square. So that is an interesting commonality that they share. Then notice these 3 all are over an even number. So that means B and C are probably really likely. Now, is B possible? I guess I'll just check B and E first. Now, let's look at this again. I probably want to check B and E first. Well, okay, hold on. 6 is multiple of 3, 9 is multiple of 3, and 9 is multiple of 3. So E is very interesting. So I'm going to check E first. Now, what I just used here is a top secret guessing method, but it only works 50% of the time. But it's top secret, so maybe I'll tell you guys about it some future day. But I think E is the most likely answer, so I'm going to check E first. Okay, if E doesn't work, I'll probably check B then, and then maybe C, and then A, and then D. So when n equals 24, there are many things. What is ratio D over S? Okay, that shouldn't be too hard, right? So let's say D is 9 and S is 16. D is 16 and D is 9. Okay, well, what is this little white gap here? There should be 9, 16. There should be 9 times 25 plus 9 times 16, I believe. 9 times 25 plus 9 times 16 is 9 times 41, which is 369. So each of these is 369. Wait, what am I doing? This is very questionable. Wait, I am. Okay, this is actually doable by just plain algebra. I don't need to guess ratios. Um, yeah, this is just plain ratios. I don't need to guess area. So 24 times s, 24s squared. No, 24s. Okay, open parentheses 24s, close parentheses squared is 64% of the other thing. And 64% is 8 over 10 squared, right? So that's 4/5 squared. So that means um 24 24s is 4/5 of something. That means 30s is equal to the other thing, which is the side length of the larger square, 30s. Um, yeah, that sounds about right, right? Yeah, that sounds about right. So 30s is the length of the square. Um, but what is the length of the square? That's just 25 times, because like there's holes, there's 25 holes. 25 times d plus 24 times s is 30s. So that means 25d is equal to 6s, which means my guessing method is horrible and the answer is just A. Yeah, probably A, right? Okay, whatever, guessing method. I'm sad that it did not work, but, I'm also happy that the question isn't too hard, actually. Let me just check again. And the idea for this is let's say we rotate the square to be 45 degrees and then we turn on gravity, then all of these green squares sort of fall on top of each other, right? And when they make a smaller square, which is 64% of the area, which means its side length has to be 4/5. That means the side of all these s's has to be 4/5 of the total. So the ratio of the s's to the d's has to be 4 to 1. So 24 times s has to be equal to d. Oh no, sorry, 24 times s has to be equal to 25 times d, something like that. Um, 25 times, okay, 100 times d, right? Okay, 24 times s has to be 4 times 25 times d. Yeah. So that means 6 has to be 25d, so d over s has to be 6 over 25, which is A. So the answer, I believe, should be A. Problem 25, rectangles R1, R2, squares, bunch of squares. Okay, combine rectangles. Oh my goodness. What the heck is this question? What is silent S2 in units? Isn't this a pain, right? Isn't this such a pain? Wait, it's not a pain at all. So this is not a pain at all. Let's say S1 has sine length x, S1 is sine length y, and S2 has sine length 3. Then we see that x plus y plus c is equal to 3322, and x minus y, so we're going here and then we're setting back, and then we're going again by z. So x minus y plus c is 2020. If we take the first equation, subtract the second one, and then divide by 2, we get the answer, which should be S2, the side length. So we just take this minus this, which should be 1302, and divide by 2, that should be 651, and that should be our answer, should be A. Less than side length of S2 should be A, 651. Now, is that true? Let me just check over 1302 divided by 2. 651. Yep, should be A. Okay, now it's time to check all our answers and see how well we did or whether we sillied every single question on this test. No, the answer key doesn't work because I don't remember the questions. So we're just gonna have to go through solutions, I guess. 24th, that's what we said. Cool. Problem 2, we said what did we say? We said 15. Yep. Problem 3, what did we say? We said 1920. Yep. Okay, problem 4, we said like 37. Yep. Oops, we said like, what did we say? Yep, that's what we said, because 75 divided by 5 is 15. This one, okay, this one was kind of a pain. I don't even remember. No, I remember. We said A for error, and so it has to be A. Yes. 4 distinct digits, what did we say about this one? I think we said C, 15. Yes. Okay. This one was Ricardo. Ricardo. What did we say about this one? We said 2018 times 4, which is C. Yep. We counted this one, we said 20. Yep. Problem 10, this one we said like C12. The Steel Tiger. Yes. Problem 11, this one I think we said 24 because 36 minus 12, I believe. Yeah. Should be E. Yeah. Okay, we said 10 for this one. A. This isn't really a problem. 13, what did we say for this one? We said Jamal puts 9 purple socks. So it should be B. Yes. This was kind of a pain. We almost made a mistake and chose C, but we actually said D was the answer. Aha. Indeed. It was D. Indeed, it was D. Okay. We said this one was 75, right? Yeah. 75% of 100 is 75. Now, this one we said B was 5 because 47 minus 42 is 5. Yep. Okay, how many factors of this? Okay, this one was kind of a pain, but in the end, I think we decided 12 minus 5 is equal to 7, so it should be B. Yes. Okay, here was a trick question where it's not a square, but it's actually pretty much a square. So 16 times 15 is A, which is 240. Yep. A flippy number, I think here we decided we almost said 3, 6, and 9, which is only 3 solutions, but in the end we found 50505 because 0 is also multiple 3. So here we actually have 4 solutions, which should be B. And that is it. Here we said B, 24.2. There we go. On this checkerboard one was really a pain to deal with, but we said A in the end, 35 minus 7. There we go. I'm curious if anyone did my way. Hey, this is my way. This is usually like the best way. This is the way to do it without thinking. If you have time, you should read this. Basically, we put a number in each white square denoting how many ways there are to get to it. But the problem is, like without a pencil, there's really no way to fill these numbers in, is there? So that's why we had to try to figure something else. What should we do with this? Now this was a pain. There isn't really anything clever. In the end, we said 83 E. And there we go. Yes. 23, I think in the end we said B because you just need a B leave, and the answer is B, 150. And we did it this way. Now, problem 24, I think our guessing method failed because it's not actually E, but it's actually A. So let's see if that's correct. 6/25. There we go. Yes, using answer choices. We almost took this path, but then we noticed if we just rotate the square and then use gravity, we can shrink all these squares into one big square, and it's just much faster. $25, this is not a very hard question, but you need to notice the algebra. It's just A, 651. And there we go. And that is that. That is a 2020 AMC 8. I am curious where the faster solution is. Ah, yes, this is the faster solution. Yep. Okay. Anyways, that is 2020 AMC 8. Hope you guys enjoyed this pencilless speed run. I still do not know what our time was, but whatever. We have a 25 out of 25, which really isn't that impressive because, I mean, like, this is the AMC 8, right? But anyways, hope you enjoyed, and see you next time.